The second question is, how big should your wind tunnel be? Say that I'll try to draw an F1 car. You know, F1 car looks something like this, right? I apologize for the bad drawing. So, but F1 car in the side view might look something like this. And then I can basically put a wind tunnel, correct? Now my question is, what is the size of this box? How big should this box be? Jennifer says 3 times the length of the car in the front and 5 times the length of the car behind. Does anyone else have any other ideas? Sunij Raj based 5 times based on the F1 car. Okay, so that's why I'm asking, like, what is it? Rupak, it should not interfere with the boundary condition. Exactly, that's exactly correct. But which boundary are you talking about, Rupak? Are you talking about the inflow boundary or the outflow boundary? Things that we are putting inside the circle, right? That is what you call as a boundary. The laminar flow of wind towards the car. Okay. The front need not be long, but the exit length needs to be long, right? So how are you making these claims? Especially for your upstream region, right? Remember, your flow initially is going to have a uniform velocity profile. That's how wind tunnels are created. The wind tunnel has physical walls, top and bottom, right? So what's going to happen is there is going to be a boundary layer that gets developed in the bottom of the wind tunnel, obviously. So one of the things that people want you to validate is your boundary layer development should match with what is reported in the experiments. So if experimental data is available, you just make sure that you follow that for the inflow length, meaning the upstream length. This is called as the upstream length. So if experimental data is available, make sure that you follow that. As far as your outflow is concerned, it's not 5, it's at least 10 times the length. Why is that? Why is 10 times seems really excessive? So if your car is like 2 meters long, 20 meters on the downstream, that seems like such a big domain. Why do people do this? Well, and what is the factor? Well, it depends on the size of your wake. So what is a wake region? Wake basically refers to the low pressure region where once flow separates, you will have really low pressure. And because of this low pressure, you will have flow recirculation. So the idea is very simple. When pressure becomes low, usually the flow here is taking place only in this direction, correct? But when pressure becomes low in the wake region, flow comes like this. And then because of this, there is a vacuum. So basically flow is kind of getting pulled into the vacuum and you start getting a recirculation region. And this recirculation region is also going to move, making the process very dynamic. So if I basically set up my fluid boundary conditions, so let me just use a different color. If I put my boundary condition exactly in this location, what's going to happen is the solver is going to get confused because a boundary condition, if you remember from differential equations, I'll just type a very simple differential equation. dy by dt is equal to e power t. So how do you solve this? You just say integral of dy is nothing but integral of e power t dt, right? Now, when you integrate this, I'll get y is equal to e power t plus c. How do I solve for c? Well, that is where boundary condition comes. When t is equal to 0, y is equal to 0, something like this, right? You give some conditions. These are called as your boundary conditions. Now remember, in CFD, you're solving PDEs. So in PDEs, you have a boundary condition here in this area and also in this area. You need to provide that, and the boundary condition needs to be a constant for a given time step, which means what you are basically saying that here the pressure is the same. In this blue line, you're saying that the pressure is the same. However, when a wake region is present, the pressure is not the same. So that is why you take this blue boundary, you put it at a very far distance so that in that location, your velocity vectors are still parallel. So on what factor does this, like how did I come up with this number 10? Well, that is purely from experience. So for example, you can take a passenger car. For a passenger car, maybe it could just be 5 times the length. If you take a truck, maybe that is 7 or 8 times the length, right? So as a factor of safety, what you can do is you can just say that if my downstream region is 10 times the length of the car, I can be certain that there will not be a backflow and my boundary condition value will be met correctly.